Hello and welcome. We have with us today Dr. V Narayanan, Secretary, Department of Space and Chairman Isro. He's taken over the reins of Isro at a very challenging and exciting time last month. I'll first ask you about the most exciting mission that the entire country is looking forward to, that is the Gaganyaan. What is the status now and what are some of the critical processes needed to be completed before G1, that's the first uncrewed missions?
See the current status. We almost completed the human rating of the launch vehicle. Human rating, when you say human rating, it means like this. We have to improve the margin of the launch vehicle, improve the redundancies of the vehicle in order to improve the reliability of the vehicle. So this we have done lot of tests, experiments, and we have almost completed. Then coming to the second portion of the major development, the orbital module unit. Orbital module unit is under realization, development and under realization. And then third part is the environmental control and safety system. Because if the human being has to be taken to orbit, we have to maintain the pressure levels, temperature, relative humidity. Then the carbon dioxide has to be kept under control. So to do that, we have to have the total development. That is in the advanced stage. Then in the event of any issues happening, either when the Gaganyaan-3s are in the vehicle or during their travel, then they should be totally safeguarded. So we have developed a crew escape system, basically fast burning solid motor system. So in the event of any problem happens, immediately that system will be actuated and the human being will be taken out. Now the launch vehicle will take them to 170 kilometers. From there we have to take it to 400 kilometers and keep them safely. So for that associated propulsion system, everything we have developed. Then in the return journey also we have to reduce the velocity and we have to bring them safely. So initial phase, the propulsion system will be used for reducing the velocity of the module. Then in the final phase we are using parachutes. And then those developments, everything is going on. Now this year we are targeting the uncrewed mission. And before that, lot of experimentations are already done and some more thing has to be done. One experiment is the demonstration of the crew escape system. In fact, last year we had a flight, test vehicle 1 flight, and we successfully took the module to some level. Now we are planning to do the second demonstration because it is at different altitude we have to demonstration. So that activity we are going to do. Then, to demonstrate the parachute and all those recovery process, we were planning the airdrop test. Because you take the entire module and drop it by helicopter, you take it and drop it, and then how the entire system performs, how the parachutes deploys, how it is working, all those things we have to demonstrate. And first uncrewed mission will be a near equivalent module, unpressurized compartment, and we are also going to use, instead of our crew, we are going to have a humanoid that is already developed totally, a Vyamitra, that is name is Vyamitra, so that is totally developed. So now parallelly we are building that vehicle, and before we go for the even first uncrewed mission, we want to demonstrate couple of experiments. So now we are doing all parallelly, but then priorities on the test vehicle demonstration, those things we are planning. Then of course we will go for the first uncrewed mission. Once it is successful, two more uncrewed mission followed by the actual human space flight mission.
So to get to some, just to get to some specifics, sir, the test vehicle demonstration 2, will that precede the uncrewed mission or will
that's what we are planning.
So is that expected sometime around March, April? So can we expect it around that time?
The date we are not fixed, but then that's the type of target, maybe May time frame is the type of target we are planning. But the exact dates are yet to be decided.
And there should also be a pad abort test, I understand, because the one we did earlier was many years ago.
But we are planning these two before the one airdrop test, before G1. Then there are so many experiments has to be really done.
The airdrop test, the helicopter issue has been sorted out now.
Almost sorted out.
So that we can expect this year sometime.
That's what we are targeting.
In terms of some of these big ticket missions that the Prime Minister has set a vision for in the next decade, and then slightly longer time frame also we are looking at, is also crucial missions are back to the moon. One, a joint mission with Japan that is being designated as Chandrayaan-4, but before which ISRO will attempt its own lunar sample return mission with Chandrayaan-4. So, how has the progress been with Chandrayaan-4? So, the team was identified, I know. So, what has happened so far, and what are some of the things that you can share as on date?
Say the the Chandrayaan-3 mission, we successfully soft landed near South Pole of Moon, and India was the first country which accomplished that mission, 23rd August 2023. And not only accomplishment, not only soft landing, then the rover came out safely, and then we had lot of payloads, and we have discovered minerals, then seismic activity, then the thermal gradient on the surface. Like that, lot of data we have got.
And then the hop and bringing back the orbiter.
That is very, very important. In fact, the hopping experiment, and after landing and taking and again moving to another place, that is another experiment. Then the propulsion module we have brought back to the Earth's orbit. So these are all really a very, very major accomplishment which was done. Now coming to Chandrayaan-4 mission, it is different class of mission. Chandrayaan-3 only we soft landed and rover came out and we did experiment. Chandrayaan-4 is the mission meant for soft landing near the South Pole of Moon, taking the sample from Moon surface and bring it back to Earth and carry out experiment. That is the mission. But now if you see the satellite, let me tell a couple of important things. Chandrayaan-3, the total mass of the spacecraft was close to 4,000 kg, 3,900 plus kg. Here it is something around 9,200 kg, and which cannot be lifted to the geotransfer orbit. GTO, our capability today is hardly 4,500 kg plus. So we cannot lift the entire spacecraft in a single rocket. So what we are planning is, there are basically 5 modules in that, and two modules in one stack and 3 modules in another stack. 2 separate launches will take place with 1 month gap using our LVM-3 vehicle, and this will be taken to Moon's orbit. Then there it will be docked, 5 modules, everything will be docked together. Then the propulsion module, it has got a propulsion module, that module will take it to Moon's surface. On the way, it will be getting dropped. Then remaining 4 modules are there. There is a ascending module and there is a return module. And then the 2 modules will go and land on the Moon surface, and one of the module will come back and get docked with the remaining 2 modules. Then when it is landing, the sample will be taken, and the sample will be brought by the module which is coming back and getting docked in the Moon surface, and that sample will be again transferred to the re-entry module. Then finally the re-entry module will come back and land. And it's a very, very complex mission wherein you need to do docking, undocking, again redocking, lot of things has to be done. And then the mass is also different, and that is the mission what we are working. In fact, the project is totally approved. Right now we have completed the configuration design, and now the design of various subsystems are going on. For example, here we need to have another high capacity propulsion system. That design, liquid propulsion. In fact, before I came and took charge, and we were in the process of reviewing the design aspect. Then there are payloads which are involved. Then there are robotic arms which are required for taking the sample. And so it's a huge gamut of activities. So entire development activity is accelerated to meet the requirement. So that is about Chandrayaan-4 mission. Chandrayaan-4 mission. Then coming to the LUPEX mission or Chandrayaan-5 mission, based on our demonstration of Chandrayaan-3, the Japanese, they were fully convinced that we are capable of handling this type of mission. So it is a joint mission of JAXA, which is the Japan's space research organization, and Indian space Isro. Together we are going to accomplish this mission. The difference is, again it is a mass is high. In fact, the landing mass itself is almost 4 times of the Chandrayaan-3 landing mass. 6,200 kg we have to land. And the rover, the Chandrayaan-3, the rover was around 25 kg. Here it is going to be around 350 to 400 kg. And it is a joint development. Rover will be developed by JAXA team. Lander and associated propulsion system, Navy, everything will be developed by us. And the launch will be done by Japan. So it's a combined program. Of course, the data will be shared by both the countries. So that is the mission on which the configuration study is over, and now we are in the process of the design and developing the hardware.
So for the JAXA, Chandrayaan-4 or the JAXA mission LoopX, we had to develop a slightly more powerful engine for the lander. That was one of the things work was going on.
Yeah.
Has that progressed, sir?
The project is approved and the design is completed. Now we are in the process of hardware manufacturing.
Okay. And for Chandrayaan-4, sir, you explained about the 5 modules, and all the docking and undocking would happen on the lunar orbit.
Not only lunar orbit. For example, that first 2 modules, two module plus another one vehicle, 3 modules, both will be taken to Earth surface, Earth orbit. So the docking will happen first in the Earth orbit. Then from there, the propulsion module will take it to Moon's orbit. And there, of course, propulsion module will get separated on the way, almost close to 1 lakh kilometer. 4 lakh kilometer we have to go, so almost close to 1 lakh kilometer it will get separated. Then the remaining system will move and go to Moon's orbit. From there, 2 modules will get separated, and one ascending module, and that module will totally get separated and it will land. After landing, the sample will be taken, and one of the module will return back.
Okay.
And that will get docked with the remaining 2 modules. Then all the 3 will try to move. Then finally the return module, where the sample is there, that will be coming back and landing.
Okay. And sir, you spoke about Chandrayaan-4 and there was so much talk about docking. So as soon as you took over, there were 2 important missions that you undertook. One was of course SpaceX and the 100th launch. Can you tell us a little bit about what has happened since then? Because there was a lot of excitement with the docking, but we understand that there could be more docking attempts done, and you're waiting for a window, or how has the power transfer happened within the satellites, and when can we expect the undocking and docking back again?
I took over as chairman Isro on January 13th afternoon. And by that time, in fact, last year end, we launched the SpaceX, and 2 satellites, each 220 kg, was rotating with a velocity of something around 28,400 km per hour. And on 16th morning, in fact, when it was launched, it was having, both satellites were having a distance of almost 11 km apart. It was rotating. Then using the propulsion system, inertial system and cameras, everything, gradually the speed was reduced and the gap was reduced. And finally on 16th morning, we could successfully dock both together. I think for the audience I can tell you, imagine 2 buses are going on the road with each traveling with 100 km per hour speed, and then with a gap. And if both has to be get docked, a lot of things has to be done. Number 1, you have to come exactly within millimeter level, you have to align, and it has to get docked. And that itself is, one can imagine what type of difficulty when both are moving, what type of difficulty it will be there to dock. And this exercise has to be done in the space, where 2 bodies are rotating, and you have to exactly understand the orientation using inertial system, and you have to operate the propulsion system, and you have to move with the right velocity, because it has to come in a very slow velocity. Then finally you have to, using all the algorithm, everything, you have to clearly understand. Then finally you have to dock. So this was a major accomplishment which happened on 16th of January. And please understand, India is the 4th country which has got this capability, and we have done the docking. Now after docking, and docking is a very complex process, and successfully docked, and both the bodies now today as a single module rotating and going, and everything is controlled. Now what we have to do is, we call it as a power transfer, because one satellite to another transfer, this one you transfer the power, and finally control. When 2 satellites were rotating separately, both were controlled separately. Now together, now we are controlling as a single body. Then the power transfer has to happen. Then, as I explained, when you are going for a mission like Chandrayaan-4 or other missions, I will come back, multiple times this docking, de-docking, everything has to happen. So here we are in the process of landing. Because first time we have done this experiment. It is not that once you dock to story is over. And we are going to do multiple times. Redock and again try to dock and try to understand the technology, complexity involved, how to manage the entire thing. So this we are planning. Now the satellite is in a particular elliptical orbit, and to do this you need a lot of power. And power generation is not constant in all the places. So we generate the power and utilizing the power, and we do all these experiments. 16th we have done. Now we are planning to do somewhere March middle onwards we are going to restart this activity. And it is not one time affair. Even after that also couple of times we will do, because idea is, are we capable of doing repeating multiple times, how precisely we are doing multiple times, and how our algorithms are capable of handling, how the systems, entire inertial systems are working, how the propulsion system is performing. So it is a multidisciplinary game. So to employ this for future application, we are going to generate lot of data. So that is what is planned. So right now, the one more thing is, whatever experiment we are going to do, we have done a simulator, ground simulator, and whatever we are planning, we are doing in the ground simulation, and get convinced ourselves, yes, our understanding is correct, then only we execute, because we should not do any mistake, so that is the process in which it is going on. So this mission will take a lot of time. First docking was very, very crucial, and we have completed and we have declared to the nation, but now lot of experiments are planned.
So it's quite exciting, sir.
No doubt it is. Say any new learning, it will be quite exciting, and that application is so good. Not only Chandrayaan-4. Another thing is, India is going to build our own space station, and space station you cannot build and take it in a single rocket. So we are going to have 5 modules, and first module we have got approval, and then we have to build 5 independent modules and take it through different rockets, and there you have to go and dock. Not only that, the space station once you built, then human being can be taken, and some like that. This is another application. Then we are talking about Honorable Prime Minister has given direction to work on the crewed mission to moon. And when you talk about crewed mission to moon, 2 options are there. One is you build huge size of rockets and make it as a single module. But then that rocket, after this, what are you going to do? So economically, we have to really understand. In our country, we have to really look at all aspects. So we are not going to build a huge rocket. We are going to have a rocket, and we will have multiple modules. Maybe right now our thing is 2 modules. You take it and dock, then carry out the entire thing. So thereby, lot of application is there. So the space docking experiment, whatever we have done is a initial step, but it was a grand successful step. First attempt, first time we have docked and we have become 4th country in the world. And then lot of experiment has to be done, and it is basically a learning process. Multiple times you do, and then at a different orientation and do, and then learn, and whatever you learn, then based on that you build the new systems.
Yes, and the 100th mission?
That is, you know that we had the first launch of the launch vehicle in the year 1979, SLV-3. If I am correct, E1 was launched. The project director was none other than APJ Abdul Kalam ji. And then chairman was Professor Satish Dhawan, a great personality. And from that, we have come a long way. Till today, we have developed 6 generations of launches. And we have accomplished a lot of launch missions, including a couple of experimental missions also. And this year, after I took over, January 29th, we had the 100th launch from Sriharikota, and that was a GSLV Mark II vehicle. GSLV Mark II is the most complex vehicle what we are having, and of course there are 5 storable stages, liquid motor, solid motor, then cryogenic, indigenously developed cryogenic stage, for which the technology was denied to us, and so that is the rocket, GSLV F-15 rocket we built, and then of course the navigation satellite NVS-02 was the payload, and this performance of the rocket as the 100th launch was so precise and exciting. And in fact, whenever you go for GSLV launch, we used to have little tensed moments, because in the past we had faced a couple of problems, but then we have learned the lesson, but it was a perfect launch, it placed the satellite in the elliptical orbit. Right now, the satellite is healthy in the elliptical orbit. And in fact, we already communicated we could not rise the orbit. But then in the elliptical orbit, it is safe and controlled. Everything is there, and we are going to study the feasibility of utilizing, keeping the elliptical orbit. Maybe little orbit size will change, and how to utilize for the PND service. So this is what right now we are doing. And the 100th launch was a so perfect and exciting launch.
So speaking about how the 100th launch happened and how ISRO has developed 6 generations of rockets now, the next one is going to be really crucial for a lot of future missions, the NGLV. What is the status and progress of that, sir?
Say our first launcher, the SLV-3, the capability was something around 35 to 40 kg to low Earth orbit. And from that, the heaviest Bahubali rocket what we are having today is the LVM-3 rocket, capable of taking around 8,500 kg to low Earth orbit. Now, government has given an approval based on our requirements, the next generation launcher NGLV. And the vehicle, just I will explain, the lift-off mass is around 1000 tons. And the height of the vehicle is 93 meter height. More than 30-35 story building height. That is almost compared to Mark 3 vehicle. Mark 3 vehicle is only 43 meter height. This is 93 meter height. And this is going to have totally 3 propulsive stages. The core stage is a liquid oxygen methane stage powered by 9 LOX methane engines. Each will generate 110 tons of thrust. And second stage will have 2 LOX methane engines of same type, same class rather, with something around a propellant loading of something around 120 tons. First stage propellant loading is 475 tons. And upper stage is a C32, 32 ton propellant loading, liquid oxygen, hydrogen based cryogenic stage. That stage is totally developed. And it also will have 2 strap-on motors. And right now, if you ask me the status, the entire configuration study is completed. We are in the process of development of subsystems. For example, engine. And 11 LOX methane engines are required. First stage 9, second stage 2 engines. And this engine design is completed. And now we are in the process of review and giving clearance for fabrication. Similarly, the mission study is completed, and rocket structures, tankages, all design. We are in the design phase right now. And parallelly, we are also discussing with the industries for manufacturing. So that is the place we stand. Plus, the test facilities are required. So those things, all the design-related activities are in the advanced stage.
Speaking of industry participation, the PSLV contract with L&T and HAL has been done several months ago, and they were expected to launch, I think, at least by the end of last year, and that has now got pushed to this year. Can we expect that launch to happen this year, sir?
Yeah, surely that is going to happen. So we have signed contract for 5 vehicles, PSLV vehicles, with the industry consortium consists of HAL and L&T. And the first launch is expected somewhere in the 3rd quarter of this year.
Okay.
In fact, the rocket is in the advanced stage of realization, and we are hand-holding them, and then we are in the process of rolling out the first rocket.
That rocket is also expected to carry some interesting satellites, experimental ones.
Right. It is called a technology demonstration satellite, wherein we are going to use along with chemical propulsion, we are also going to use electric propulsion. We are going to, in fact, there are 35 experiments, experimental things we are going to demonstrate: indigenous atomic clock, quantum payloads. So lot of things are in the store, and right now the payload getting realized.
So these 35 will go into this mission, or this is this mission? Okay.
Mission. 30 or 35, that we have to take a call. Right now our target is around 35 new.
So including an electric propulsion thing.
Yes.
That has not been used in satellites so far by ISRO.
We have used earlier, if my memory is correct, GSAT-19, that was a 75 milliNewton thruster, SPT. But then we got that with the support thruster wire from other country, but then associated system like power processing and control unit, all those things we developed, propellant tankage, all associated components we realized, but thruster we got the support from others. But here it is a total indigenous thruster, high capacity thruster, 300 millinewton thruster, and that already the development is almost in the final phase. We are carrying out the life cycle test now. In fact, the entire development is happening mostly in Valimala, LPSC Valimala, where I was the director. And now, of course, my team is doing that job, and we are expected to complete the development. And it is going to be an exciting mission because of two reasons. First, rocket getting rolled out from a industry. Second thing is we are going to have exciting payloads in that.
Some of that would also include communication, how different
so
bands
many
can,
things are there. Yes, lot of things.
and the atomic clock, of course.
A lot of things are there.
And so coming back to Gaganyaan, so in terms of tracking and network of ground stations, quite a few announcements have been made in the past. With ESA, there was recently a testing of our communication system with the ESA ground network. But ISRO is also trying to set up a few of its own, like for instance in Australia. So an important development that was supposed to happen sometime this year. I think a delegation is expected to
all are
visit.
going on well. All are going on well for us to accomplish the mission.
So what's the status on the relay satellite? So that will be launched closer to the mission. Is that the plan?
Yes, IDRSS. That also we are planning.
We'll have one or more than one now?
Right now we are thinking of one or two, but then we have to take a call in that.
Yes, and one last question. What are the two astronauts that have been shortlisted and are currently in India? What has their routine been like now? And of course, we know what's happening with a little bit with Group Captain Shukla, who's expected to fly in the spring this year. So that is another exciting mission. And if you can touch up a little bit on what kind of international collaboration is expected in the future, not just with manned mission, but in the next decade, what can we expect through ISRO?
No, international, one is, say, with respect to your question, say, as you are aware, the 4 astronauts, rather Gaganyaan-3s, we trained. And the training is a continuous process.
Correct.
Now also they are undergoing training, various modules. One is practical training, academic related aspects. Then they should have, they are continuously on training program. And 2 of them are in right now in USA. And 1 of them will fly to the ISS in the Axiom for that program. So 1 of them will go and come back safely. And that is that will happen very shortly. And then, say, when you talk about a space station, right now, Honorable Prime Minister has given lot of approvals, lot of guidelines and vision. For example, Chandrayaan-4 we talked, Chandrayaan-5 we talked. Then we are going to have an exciting Venus orbiter mission. And earlier we had a Mars orbiter mission, which was the mission I want to tell you. The Mars almost 16 crore kilometers we had to travel, and we went perfectly and made it successful. And India is the first country and only country accomplished successfully in the first attempt a Mars orbiter mission. Now we are going to have Mars 2. We are planning to have soft landing on Martian surface. Then, of course, the new Bharat space station, that work is going on. The next generation launcher development is going on. Along with that, we have been given guideline to study and configure systems for taking our own brother or sister to moon and then land safely and bring them back safely. That is by 2040 we are targeting. And we also had an exciting Aditya L1 mission, probably we have not talked. And India is the 4th country which is having a missions to satellite to study the sun. In fact, last year, 6th January, we commissioned in the L1 orbit. This year, 6th January, entire science data which came out 1 year is rolled out. And now when you talk about a vibrant space program like this, also in addition to all these scientific and human spaceflight program, you have to serve the country in earth observation, telecommunication, navigation, and Navy satellite, a couple of satellites has to be placed in the orbit and make it the signal useful for both restricted and civilian services. And when you talk about this type of huge program, including space station building, taking our own brother to moon and bring them back safely, I think it is appropriate to go for have better international collaboration.
Thank you so much for taking the time out, sir.
Okay, thank you. Thank you very much.